through tedious, you go through a lot of training. But most people are relaxed. Most people feel they are not getting to bed. Once you take salary, the biochemistry study is aimed at solving societal problems. Not just problems. What new can we do? What vision can we have? As a biochemistry student, I want everybody to have an open mind. We are trying to get very simple. What needs can we have? You don't have to be the president of this department to bring an idea. You have to be the welfare secretary or the vice president to bring an idea. You just have to think. You need to think. Have an open mind. When you think about something, then you discuss. That's what competition. When you discuss, you cooperate with other people. Then go on for them. Whatsoever you can think, you can achieve. Whatsoever. For example, sounds impossible, but you might just. This program brings things life, like you say, brings things life. You can access, you can share the link to people that are going to and watch. So there will be no limitation of I don't have transport, I couldn't attend to make sure that I cover. Us here. Now, what
Are you like, I don't think you I'm live on both platforms. No sound. No sound. No sound. No battery. Sorry, someone is calling. Even battery for this one. Like, I'm not getting anything. Check the YouTube platform whether I'll be like, not sure. Can you share this cross post? Look at I'm live. So see, you share this one. Yeah. Okay. Now look at it. Or even please. You have to get this mic. You have to take this mic. The battery, please, you put battery.
Whatever you need that is not yet, you can request for conversation. We have lots of people who are very intelligent that can speak. We have lots of
Hallelujah. Hallelujah. Hallelujah.
two, check, two, check, two, check. Okay, that's. Sorry, I'm used to the microphone. Okay, the link he just talked about is shared in the group of from 100 level to 400 link, and share it to as many as possible. To take this event forward, we would like to invite Mr. Agwaza Paul to give us the keynote speech, the first class graduate. Please jam your hands together. Do it until he's here. Thank you.
Good morning, ladies and gentlemen. Okay, like the moderator said, my name is Agwaza Paul Kene, State. I must say that when I got the invite to be the keynote speaker of this event, I was kind of scared and excited at the same time. But before I go on, I would implore you to help me give a resounding applause to the pioneers of this vision, if you don't mind, please. Okay, so thank you so much for that. So moving forward, defines biochemistry as chemical processes that go on within and around living systems. Now, I don't know if any of you here a minute your breath, or you can try. Like you're going to kick the bucket the next minute. Now, oxygen is very, very essential for life, isn't it? Okay, now I'm heading somewhere because I want you to see biochemistry as oxygen. Exactly. I want you to see biochemistry as oxygen. And have you ever wondered why most life sciences do biochemistry or require a knowledge of biochemistry? You see people in the plant sciences, vet medicine, medicine, pharmacy, the list goes on. Have you ever wondered why they need the knowledge of biochemistry? Now it takes us back to the fact that biochemistry is like what? Oxygen. You need that to be able to what? To survive. Because for life to move on, very well, without any problems, without any hitches, you need the what? The chemistry. And this is also to pay attention to the fact that as a biochemist, you are very, very important. Now, I get that for a greater percent, I would say more than 70% of chemistry. I decided to accept my fate and then come up. But beyond that, beyond just accepting to come and do biochemistry, I made up my mind that whatever is worth doing, it's worth doing what? Well. And then I set out from the first day that chemistry or several other courses. There's this sort of low esteem in the courses we are studying. Why is the reason? The reason is that you are not studying this course with the mindset or with the vision that I want to solve a problem. Okay? So you just go through that course very casually. You see, you go into the course 100 level, 200 level, 3 and 4. And all for what? For the paper. Now, I want us to write off that narrative. If you are here as a student of biochemistry, I want you to have a reorientation of the fact that you are in biochemistry, so that at the end of your studies, you should be able to solve a problem, or you should be able to solve what? Problems. That is the reason, and that is the essence, that is the core essence of you being in what? In school. And each and every course you are studying in biochemistry, I want you to know that it is important. The chemistry, the programming, languages you are learning at the point you are like, why do we need all these courses? Yes, some of us ask those questions. But when we're approaching the climax of our studies, we saw that each and every course that was in our syllabus or in our course forms, they are very, very important. And I think we also need to actually appreciate the department for doing that. When we came to the climax, we discovered that these courses are very, very important. If you look at the theme for this program, it says navigating the future of what? Biochemistry, research, innovation, and what again? Now, these things are very, very important. If you go through the courses you've been doing, you see that they highlight all these things. So whatever it is you are doing in the course is important. And the moment you take this thing serious, that will determine the starting point of your success. But if you walk through the whole thing casually, I'm telling you, you also come out with what? Very casual grades. It has to be deliberate, okay? For you to get something useful out of the course, it has to be deliberate. You have to make up your mind. You don't just walk through the course grudgingly or trackingly as though you were forced to do it. Even if it's not what you applied for, you'd have to make up your mind. And when you make up your mind, your eyes are being opened to the vast array of opportunities that you'd find in biochemistry. Most times when they say that biochemistry has a lot of opportunities, we may tend to even laugh it up, that what opportunities. But really, if you look at the world today, it's like research is the hub of everything that is going on. Talk of the medicines that people take. Talk of the pomade, the creams you use on your body. Okay? Talk of the beverages you take. Just name it. Recently we were hit by a pandemic, the COVID-19. Usually say it takes close to about 10 years for vaccines to be approved. But it took just a couple of months to do this. But how did we arrive at this? Research. Okay? And biochemistry, yes, played a very pivotal role in these things. You study macromolecules. You study proteins, carbohydrates. Just look at these things as themes of study. We don't look at them as things that would actually help us to solve problems. You study proteins. You look at your body. Look at the cell. You see things like cell membrane. You have lipids incorporated. Now, the essence of you studying this is so that it will open your eyes to dig deeper, so that you will be problem solvers at the end of the day. It doesn't end at getting a degree. It doesn't end as getting a first class, 2-1, 2-2. It doesn't end at that. Okay, you've gotten these things, but what is your contribution to the society? How has biochemistry made you better? Or how is biochemistry going to help you to make your society better? we keep complaining about Nigeria. Yes, it may not get better if we do not have a reorientation. If we are only coming to school to graduate, get the paper, and go and live our normal lives. No, we have to start early from here, thinking how to solve problems. You don't have to wait until you get to 400 level, 3 or 200 level. You can start as early as possible. And like I started by saying, I actually appreciate, and I'm actually very happy with the pioneers of this vision, because I see this as a great move, and I feel that it's going to be sustained. And if this will be sustained, then I really believe that we are going to be achieving a lot in this department with the vision they have brought forth. So I want to implore you to be intentional, very, very intentional about your studies. You know, looking at it as an avenue for you to be able to solve the problems in your immediate community, and then, you know, the society at large. Biochemistry is very, very big. And with biochemistry, I bet you can go places. You can do things. So have that reorientation, that you're not just studying biochemistry just to obtain that paper. I don't know whether you've wondered why people in courses like pharmacy, you know, medicine, engineering, and some of these things, you know, there's that prestige. You know, they carry themselves, even if they don't know what they are studying in those courses. You can't tell, because they are proud of studying those courses. Why? There is a vision. They know that at the end of the day, I'm going to be this. But you're studying biochemistry, and then, you know, you're just going through the thing, draggingly, grudgingly, as if you're studying shit. You give value to what you're studying. Is anybody getting me? You give value to what you're studying. You can make biochemistry to have that prestige that medicine has. You can make biochemistry to have that prestige that pharmacy have. If you make up your mind, you know, you are deliberate, and then you tend to show people that you really know what you are studying, so that beyond just the course, you know, you actually have a drive as to which you are doing this thing. Like I said earlier, even if you didn't apply for biochemistry, it is not an excuse. You know, there are times that Dr. Marf will always tell us about Mother Nature. It may be that Mother Nature is pushing you here to solve a problem. There are other people that did pharmacy, read medicine, but they are still going through the route of research, and then they'll still find themselves in what? So we hope for the very best in the biochemistry study community, and we pray that just beyond here, this program will actually go a very long way, and it will not just stop with the pioneers. It will continue even after they are long gone from this place. And then someday we would be grateful that people thought of this to come to birth. So thank you so much. I appreciate it.
I need you to put your hands together. More. Wait, you think it is easy? Okay, to take us further, I would like to invite Dr. Mafulo Simon, the exam officer, to give a speech on the biochemistry study community. Please, can you welcome him by putting your hands together? Do it better.
Thank you very much. First, I'd like to recognize the president of the society and all his officials. I think from the very first time that I met him, I have this feeling that if given opportunity, he will change things. Because I specifically want to mention this. I may not have told him, but when we had problem with our light, he came to me and said, "Sir, is there anything we can do? We can actually fix the light." I said, "My friend, relax. Let the university do what they are supposed to do." But he showed me that if given opportunity, he will want to bring about a change. So the president and all his officials and all the 100 level, 2, 3, and 400 level biochemistry students are here. But it looks like only few 400 level students are here. And the assistant, or the main class rep, right? Assistant, okay, the assistant class rep is here. Good morning, and Paul here, the first class, student, and I happen to be his exam officer, and I was also his level coordinator. So I am aware and I know that his first class was consistent from 100 level to 400 level. I'll tell you something a little bit about first class. So good morning to all of you. And those who have organized this program, I think is important. But first, I want to say that biochemistry, in addition to what he has said, I will not repeat what he has said. There is a reason why the biochemistry program was established. Just like any other basic science discipline, the biochemistry program was established to meet the needs in the Nigerian universities, right? Because biochemistry understands more about the biological sciences. So if you will have to study the life sciences, then it is biochemistry that serves as the link, right? Chemistry and biology, more knowledge was discovered. And so there was a need for a link, a discipline that can interpret the chemical processes in biological system, and that was how biochemistry came to be. And today we have biochemistry in our universities. And I want to tell you that why is the degree classified? Have you ever cared to find out why? Degree is classified into BSc, MSc, and PhD. And BSc in all levels of study will not lead to specialization. So BSc gives foundational knowledge. So if you have that idea that BSc gives foundational knowledge, it is in MSc that you have the license to practice. Then it means at MSc level you acquire more specialized knowledge in a specified field where you have obtained a foundational knowledge. Then PhD now, you have acquired special skills in research, and you now have license to be a faculty member in a university and lead research in a specific area in your field of studies. So all the BSc programs will not lead to specialization, and they only give you foundation. And I think if we know that, it will help us. So in biochemistry, for most of our students, I just want to speak based on the experiences that we have here in University of Jos. Like Paul said, many people giving biochemistry initially did not plan to come to university to read biochemistry. Some of them even got to learn about biochemistry only after the admission have been given to them. Right? You apply for medicine and then you saw biochemistry. I remember my classmate then say, "What is this? What is biochemistry? Okay, what role are we going to play in the society?" And that is where the problem is. In our own country here, there is no defined domain for biochemistry. there is a defined domain of contribution for medicine. Yes, you know you will be a doctor, you will be in the hospital. Many years ago, there was no BMLS. It was biochemistry that was taking and, covering those areas. But our pioneering fathers did not help us. I must say this, because we also face this. Our pioneering fathers did not create a niche for us, so that all biochemistry, remember that clinical biochemistry is BMLS that is taking it now. And now if you are going to the hospital for IT, they tend to say that you are not fit for the place, right? But everything that we do in the clinical biochemistry is what BMLS is taking now. And in Nigeria, basically, you will see that most of this domain, if you want to go to drug, pharmacy will say they are the pioneers, they are the owners of that domain. So you find out that the reason why biochemistry students sometimes look as if they are stranded is because there is no specific area where you will say, this is where, after graduation, this is where you know it belongs to biochemistry student. But there is a place where you can make contribution. And that is what I want to emphasize, research. If you look around here, you can see we struggle to carry out our projects, isn't it? Right? In the past, it is people from the community that come to university to conduct their research. But now our project, we send our students outside to go. It means there is a change. There is a change. There is a paradigm shift, and we can change it again. We can introduce, you can imagine that if biochemistry student here will now say, okay, in order for research, let's establish a mini lab that can take care of the needs of project students in University of Jos. And you can buy enzyme kits. Those who want to do liver function tests, you charge them and run the analysis for them. I'm telling you, as small as that, it can start from here and it will change the narratives. And if tomorrow people are coming to biochemistry to solve their problem, you can decide to bring policies that when people know that you are relevant, they will give you a say, isn't it? So for biochemistry, there is so much about biochemistry. And you cannot discard biochemistry. Even those who claim that they don't want biochemistry, there is no way you can throw away biochemistry. Biochemistry is a runabout. I want to use what you know. In a runabout, from whichever direction you come, you will enter and then leave. Let me tell you, a biochemist can switch from one discipline to the other for as far as life sciences is concerned, and he will still be okay. Now, as a biochemist, after graduation, after BSc, you can still go back to medicine, and you will cope, right? You can go to pharmacy, pharmacology. Many of my classmates now, after BSc, they did pharmacology, MSc pharmacology. Someone in chemistry, even if they are admitted, they will not fit, they will suffer. But biochemists, pharmaceutical chemistry, if you hear of pharmchem is like biochemistry. Pharmaceutical chemistry, find out from pharmacy students, they will tell you. So most of this discipline, there is no discipline that can run away from biochemistry. It's just that our forefathers did not create a niche for us where we will say this is where we belong. But we can do that through research. We can expand our horizon. In the Western world, in US, now we have ASBMB, that's Association of American Society of Biochemistry and Molecular Biology. If you have time, you can search their site. They have career progression. You know, they can explain, they have opportunities that they can give you. You will learn more. And if in case there are other scholarships that they offer, if you are privileged, those scholarships are extended to other parts of the world. They can take you for 3 months, 2 months. There are different programs that you can go there and study for some weeks, 2 months, 3 months. And if you go out, you will see biochemistry in real play. The reason why you still seem to see biochemistry as an abstract course is because we don't have the practical applications that we ought to do. But through the grant that we've gotten, you can run PCR analysis now. Through Richard and London, their grants, we have PCR machine here. You can do electrophoresis. And those techniques will sell you out when you go out. So while you are here, you should learn to do what you can do while you are a student. Once you are given a program, try your best and your best to understand why you are in the program and learn the basic things that you need to learn at this level. You see, the bachelor's degree, you have more time. I had privilege to go to UK. When I presented my paper, a woman that works with WHO, immediately we went for break. She came to me from China and said, how old are you? And I told her that I was above 35 then. She now said, oh no, if you were 35, I would have given you, a postdoctoral research in my lab so that you can advance your studies there. Because their government pegged the age to 35. So for you that are young now, you have opportunities out there. Biochemistry lives beyond the horizons of Nigeria. And don't limit yourself just to here, right? You can find places when you go out, you can diversify. In the UK, nutrition experts work in the clinics, right? So after your biochemistry, you can choose to specialize as a nutritionist. In the military, we have forensic experts. Biochemistry can go there. In the military also, we have toxicologists. Those who will sit down and be manipulating chemicals to create more toxicants that will be used in warfare. We have biological weapons, and there are a lot of opportunities for biochemistry students. And so I want to tell you that as a biochemist, one of the area of study that is coming up is the data science. Biochemists can switch to data science, computational biology. There are a number of things that I believe that there's no way I can tell you everything about biochemistry here. But I want to tell you that specialization depends on your choice. It depends on your interests. There are many fields. You can further your studies in that area. But first thing is, while you are here, learn the rudiments, get the basics, and learn them. And there is no lecturer that can give you every detail in a class. No lecturer can give you the whole details. Whatever we give in the class, I always say is that it's a summary of summary of summary of summary of summary of summary. Right? You cannot get all. And learning is not only from lecturer to student. There can be student to student learning. There are those that are fast learners, and that is how we have been wired. There are people who learn very fast. And there are people that learn very slowly, but once they pick it, they will not forget. So the architect of the universe wired us differently, and you must learn to understand how you, at least the fact that you are here, it means you have passed through primary and secondary school, isn't it? You know how you have studied, to reach here. So, but biochemistry requires that you have a constant interaction, because we are dealing with structures that you don't see them. I heard someone say fellow metabolites, isn't it? Which metabolite are you? Have you seen the metabolites? You see, that's where the problem is. But does it mean that they don't exist? My professor used to say that Have you ever seen hunger? Right? But don't you react to it? He said that is biochemistry. So I want to leave you with this, that biochemistry is with us. And there is nowhere you will go that you will not see biochemistry. So the Lord bless you as we continue.
Jam your hands together. Do it more. Do it more. That was quite elaborate. That was quite elaborate. You know, some of us, when we came into biochemistry, hearing biochemistry from a distance, you would think that it's just one of these sciences. I was watching someone some time ago, and then the person said, if they ask you after you are done from the university, where will you be working? If you say anywhere, that means a useless course. Amen. You see, okay, so okay. Okay, let's continue. While I was talking, one of our speakers walked in. It's a person of Miss Jane Rose. Please, can you celebrate her? Thank you very much, Ma. I'm going to welcome her briefly to say something about research in biochemistry. Please, can you put your hands together so welcome her to the stage.
Thank you very much. Good morning, everybody. It's a privilege being here. It's a privilege being here because I remember a few years ago I was here, but today I am here. And it's quite a privilege seeing all your faces and to say welcome to biochemistry. Biochemistry is one department that if you know what you're looking out for, you will never regret being a biochemist. That is one thing I will tell you. Because I remember in my early days, then we were told that one of the goals to, or rather one of the ways you can actually succeed in biochemistry is if you do not hate biochemistry. Because unfortunately, we see people who come into biochemistry and they be like, what am I doing here? I don't like this course, blah, 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 and all of those stuff. Well, I must tell you that biochemistry is one of the beautiful courses you can ever think of being involved in. All right, so today I'm going to talk briefly about research in biochemistry. Now, you cannot separate research from biochemistry because biochemistry is like the foundation of biological researchers. Because for a breakthrough, for you to be able to, get something out of life sciences, you need biochemistry. Because biochemistry gives you a vivid description down to the minute constituent of life. So what biochemistry will tell you, every other course may not take headway. Genesis of medicine begins with biochemistry. All right? Now, genesis of understanding any disease whatsoever begins with biochemistry. Because you need to understand, okay, there is a problem, but where is the genesis of this problem? Now, that is where biochemistry comes in, because biochemistry understands the nitty-gritty of nature. Biochemistry understands what comes together to give you something. And for you to know the actual problem, you need to go to the root, which is what biochemistry does. So if anybody should make caricature of you that you're studying biochemistry, you beat your chest, hold your head up high, and tell yourself you're not wasting your time. Now, research is what drives development in any society. Now, the genesis of research, or what brings about research, is you're in an attempt to solve a problem, or there is an existing problem, but you want to see what are those underlying factors, what are those things that cause such problems, and that is what gives birth to research. Now, in biochemistry, we are basically concerned with research in biological systems, all right? Be it plants, be it animals, it doesn't matter. Even if it has to do with environmental research and all of those things, you still need biochemistry to understand the biological aspect of the environment. So what research helps you to do is that you try to find out where is that problem coming from. Because if you're able to figure out where that problem is coming from, out of curiosity, out of interest, you try to see, okay, what can I do to solve this problem? And that will entail you digging deep into knowledge, digging deep into what other people might have said about that problem. Because nobody on earth can carry out research extensively. You can begin somewhere, and then you get to a point where someone else will take over. So research is very, very important. In biological sciences, it's important because research drives development. Like I said earlier, it drives development. What now, you ask yourself now, what is development? Development is simply moving from where you are to a better point, to a better location. And you don't just move to a better location, you need to work towards moving to a better position. Development entails wherever there are problems, you try to sort them out. Development entails wherever there are gaps, you try to fill them. So when you're subjected to an atmosphere of research, what the first thing that should come to your mind is that I have been placed in a position where I should look for a solution to a problem. That is what basically research is all about. So if you want to drive development, you have to begin from what? Research. Now, research may not necessarily only be trying to solve problems, but in the course of research, you could find an underlying problem that was there before but was not known or seen. So we now see that research is actually an integral part of being a biochemist. And if you want to go further as a biochemist, you need to develop interest in research. Now, most of you see research when, you do projects and all of that, and unfortunately, most of you take it for granted. Not knowing that you're putting yourself in a position whereby you're valuable. Now, a researcher is a valuable asset in the society, believe it or not. It all depends on how you see it. It all depends on how serious you take it. The society would only treasure those who have value. And if you do not have value, the society treats you as you are useless. But if you see yourself as a researcher, you see yourself as a problem solver, you see yourself as somebody who wants a process to go beyond where it is, you want it to go to a better height, you want it to go into, it's called lead to a breakthrough to something. So basically, my little take, or rather what I will say to you guys right now is, right now, you are in a better position where you have to channel your thoughts or your mind towards what? Developing that mindset of being a researcher. Because being a researcher, you're trying to make yourself available to the world out there, to society out there. You're telling the society, hey, I'm useful. Hey, you can use me, or rather you can. This is what I know, and I know what I know could help in one or two ways. And before you know it, you'll see people come looking for you. You don't even need to go look for others, simply because you took the most important part of biochemistry, which is research. Simply because you took it seriously, the world will take you seriously. Thank you.
Put your hands together once again. Okay, we'll take the event forward by inviting the pioneer of this great body, the biochemistry study community. Please, can you make welcome the person of Ekom or Jehoshaphat Emmanuel? I need you to clap until he's here. Thank you.
Thank you so much. Good morning, everyone. First off, I want to apologize for starting late. On behalf of the team and everyone involved in this event, I truly apologize. For our lecturers, thank you so much for coming. Ms. Jane, thank you. Sir Paul, thank you. Sir Mafulu, we honor you greatly. Thank you so much. They are coming here, you hear them speak, they will blast your head, so get ready. They will blast your head. They are very great people. Thank you so much, the president. I really appreciate you. I am Ekomo Jeroshifat Emmanuel. For those of you that don't know me, I don't just like normal things. That's one thing about me. Anything that is normal bores me, and that's where all this started. Like me, that's where I start from. And today I'm going to be unveiling the vision of the biochemistry study community. Media, if my slides are ready, please, can I have them? Okay, so as they get that said, the reason why we are here is simple. Everybody say learn, connect, solve. Learn, connect. The first page. Learn, connect, solve. Okay. Awesome. This is my first page. So I'm unveiling the vision of learning, connecting, and problem solving. Now, let's go back how the story started. Okay, how it started. So I didn't apply biochemistry just like most of us here. I didn't fail JAMB. In fact, I got 272 in JAMB. I had connection with the VC. Like, my dad was his friend. But the day I saw my admission letter, I saw biochemistry. I was so audacious. I told my dad, JAMB is very simple for me. I went back to, I want to write JAMB. But thank God I resented to the Holy Spirit. And that was when I did a 72-hour research. I did 72 hours research on what biochemistry is. So why reject this course if you don't know what it is, right? So I went in, started my research, did some deep research. I found out that biochemistry is even a research course. So research is a culture I've built over time, and it's something I like doing. So after my 72 hours research, I said, this is what I am meant to do. So I said, let's do it. Now, when we came in 100 levels, sometimes around November, with Uti, Sir Alex, all these great people, we just came together and said, see, guys, we don't want to graduate with A4 paper, right? We want to graduate with something beyond, whether it's first class written there, we want to graduate with something beyond that. So the aim is just to study, become the best version of ourselves, right? And graduate with solid relationship, right? So after some while, can I have my next slide? After some while, as we continued, a year into it, the vision starts changing. The vision starts evolving. Yes. So we continued and then we evolved. The vision started evolving and we said, we can do something better than this, like just connecting, getting to know each other. We can start solving global problems. So 1 year into the study group, our vision began taking bigger shape. It was even beyond us. When we saw the vision at first, we were scared. We were very scared, and we had more bonding and solid relationship, like I said. So all was leading to, now this is the vision. Next slide. This is the vision, and I want you to pay attention. Now, this is the vision we arrived at. The vision is to learn, connect, and solve global problems through research. Can someone shout research? Science, innovation, and technology. These are the driving force of what we want to do, right? Now, mentorship becomes a catalyst accelerating growth, equipping individuals to navigate challenges. Now, the reason why I put that statement is we can't do this by ourselves. We did a hangout rather, and we thought that we need mentors. That's why our lecturers are here. Please give them a round of applause. These guys are going to be our mentors moving forward, right? We can't do it. We are just people coming up, so they would guide us. Can we have the next slide? Now, we have a vision. This is the mission. The mission is to create a platform for research, networking, and problem solving to the end that giant problem solvers emerge. Now, let me ask you a question. When you came here, did you meet any new person? If you don't, you are not working according to our vision, because we said connect, right? before you leave here today, make sure you meet one person or the other. The scope of connection and networking in as far as this vision is concerned is biochemistry can't do it alone. It's just a minute part of medical science. Am I correct? Now, if we connect all medical students together, we connect medical labs together, coming together, we can change the world. Who believes that? Right? We can change the world. So we can't do it ourselves. So that's why we need to connect. Right? Can we have the next thing? Okay, just stay on this slide. So we are out to provide solutions to diseases like cancer. I have a friend. Thank God Joshua is here. Joshua has a very interesting story about cancer, right? Me, I have a story of SCD. I'm an SCD warrior, right? Yes, I have sickle cell disease in my body, right? So we are out to solve this problem. Dementia. Who has heard of dementia? Right? And we are out to solve cystic fibrosis, all these problems, right? Other problems that have to do with biochemistry, we are out to solve them. Can we have the next slide? Now, this is the pillar of the mandate. We have a guiding principle. Are we together? We have guiding principle. We have pillars that are going to keep us going through this vision. Number one is research. Like the beginning and end of what I'm just busy saying is research, right? That is where it starts. We have a work ethic, right? We start from research. From research, we go to networking. From networking, we go to global problem solving. And then we want to empower people to come to this research institute, which you'll see later, to come to this research institute and have source of livelihood. Beyond that, they'll be able to rule their world in their various fields. Can we move? Okay, seems my slide is taking too long to come up. So this empowerment is going to lead us to what I call where we see ourselves in the next 10 years. But before we see ourselves, what are our values? What are our values? Someone shout rage. Someone shout rage. R-A-G-E. That's our values. We are ready at all time. That's our key values. Ready at all time. Readiness. And we are accountable. Yeah, accountability. Growth, excellence. Can we say it together? Readiness, accountability, growth, excellence. Now, these are our guiding principles. Now, the last one is what interests me. We are out to be diligent, productive, and competent. That we are so good at solving problems that even the selfish nature of men can't deny us. Right? So if you are very excellent, you are very good at the problem you solve, nobody will deny you any right. Okay, let's move on to where can you fit in? Now, pay attention. I've just been talking about the whole event and all, but where can you fit in? There are various places you can fit in. 4 places actually. Number one is research. Now, if you think that you are well suited for research, we have a research department. You have a problem-solving department. We have a public relation. It will interest you to know that everything you see here, from the setup of the projector, the setup of the media and all, is all done by medical students, right? We want to incorporate their various abilities into biochemistry. So imagine a tech biochemist, right? That's where public relation come. Now, sales and marketing, we don't have any funds coming from anywhere. So we are going to market our problems, right? Because value, when you exchange solutions to problem, what you get is value in return, right? So that's why the sales and marketing is there. Can we move? Now, in 10 years from today is 23rd March, right? In 10 years from today, let's say 2035, where do we see ourselves? We see a well-raised and equipped institution of biochemical research in University of Jos. Just like when yes, you can clap. Just like how medical students in 300 level move to Jews, right? To go and study more. We want that at a time we'll have a research institute that is hands-on practical. Are we together? That will be able to drive our vision. Now, so my next slide. Yes, I invite you to join us as we explore, connect, and solve problems. become global biochem giants. The bigger the problem, the bigger the solution. Thank you.
Jam your hands together. Wow, wow, wow. That's amazing. You know, if you tell an ordinary person, they will tell you that biochemistry is just an anyhow course. But it's obvious now. I think since you came, you've been enlightened and educated. I'm looking forward to a time that will come in such that this sickle cell, anemia, and some of these natural things will be able to provide solution to them. I believe as time continues, we are going to be learning more. So now I'm going to be welcoming Sir Bitrus Timothy for him to tell us more about the research project that is going on. So please, can you put your hands together as we invite him for inaugurating the research team. The person of Bitrus Timothy. Please put your hands together more.
Of the greatest metabolites. Are we not happy? I want you to look at someone and tell him, I'm a proud biochemist. I'm a proud biochemist. Not to take much of our time. I want to lean on existing protocol. The president, lecturers present, I want to appreciate your coming. When I first came into biochemistry, as much of us that stay here today, I didn't apply biochem. I applied medicine and surgery too. I wanted to become a medical doctor. But as the 100 level self, I was just there. I was just, okay, my dad promised me that, don't worry, my son, don't worry, next time I will change from biochemistry to medicine for you. So I was just there, and then at a point in time, I now realized, okay, what is this biochemistry? Just as Joseph Father said, what is this biochemistry all about? That was when my interest kicked in. That's when that interest kicked in. So basically, what I just want to talk about briefly is, I don't want to take much of our time. I want to talk about research. So does anyone stay here has any idea on what research is? Any idea? We'll be talking about research. Does anyone has any idea of what research is? Jojo, any idea? Well, no.
Research is inquiry for discovery. Basically, whenever there's a problem, you look into it by using science and analysis and hypothesis to come to a resolve and to make progress.
Thank you very much. Can you please give her a round of applause? In simple terms, I do not want to drag research. In simple terms, research is just a systematic approach to finding new knowledge. Okay? It's just a systematic approach to finding new knowledge. Okay, what is this research all about? Let me paraphrase from what the journalist Mr. Mafulu said in class. Let me paraphrase him. He said, no society is 100% realistic. That's just the truth. As research is there, as you find a solution to a problem, I bet you must produce another problem. That is why research is so key and so important. And as a biochemist, I want to let you know that each and every one of us there here has the ability to solve that one problem that we feel like it cannot be solved. Okay? With the vision of the president, that's the new dispensation project led by the president of the department, Ibitomi Joshua. If any of us stay here has any vision, I want to let us know that the union is open to ideas. We want to move forward. Okay? That being said, when the vision of the study community came, when I came across it, I found it as a very welcoming idea to the whole of the department. Why? Because I found out that this can actually be that excellent breaching point in which we can actually carry what is being taught in class and put it into practical. Something that you cannot see into something that we can see. Okay? I know some of us are yet to know that, but we've been talking about the DNA double helix, DNA double strands. And one thing I've noticed about the whole of biochemistry in the University of Jos is there is inadequate availability of study materials. And not just study materials, I mean, if someone is telling you about the DNA double helix or the DNA double strand, you are not able to see what he's talking about. That now brought a vision onto me. What if we, as the students of biochemistry in the University of Jos, using the small knowledge we have gotten at this level, are able to use locally sourced materials into building practical things that are there in biochemistry that people can see and appreciate. Okay? So that being said, I'm proud to say that God's willing, during the biochemistry week, which a team is already in place, we are looking at building a DNA double helix from locally sourced materials. And by the special grace of God, I believe that our dreams and our vision will come into accomplishment. That being said, I want to appreciate the president, I want to appreciate the panelists, I want to appreciate our lecturers present. Thank you very much.
Put your hands together more. You are not clapping, I say clap for him. Okay, to take this event forward, we are going to have one of our panel discussion. I need you to put your pen and your jotters ready to write, to jot, because you are going to be learning a lot. So please help me welcome Ms. Sharon Jikirit Gotao to coordinate this panel discussion. Please help me clap for her.
Good afternoon. Sorry, good morning, everyone. I stand on your existing protocol. I want to recognize the presence of our lecturers. So this panel discussion, we're going to be dealing with the students. But before we go into what we have for today, I have a riddle. Why did amino acid go to school? Why did amino acid go to school? Who can answer me? So why did amino acid go to school? Anyone? Biochemistry students. It's a biochemistry riddle. You can just try, please. Yes, sir. Because he wanted to. Yeah, close. He tried. Please, let's clap for him, but it's not the answer. So who wants to hear the answer? Okay, it's because he wanted to become a protein. Amen. So it is said that we come to school, that's on a lighter note. It said it come to school because we want to develop ourselves. And as biochemistry students, we know that long chains of amino acids join together through peptide bonds to become a protein. So basically, for the sake of our talk today, we'll be focusing on biochemistry beyond the classroom. BT said something that caught my attention. Many of us came to biochemistry not because we actually planned on studying biochemistry, right? How many of us applied biochemistry? I'm sure very few. Funny enough, I applied biochemistry with my own hand, but it's not what I wanted. So we're going to be looking at biochemistry beyond the classroom. Some people feel like biochemistry, you just finish and then you do a POS work. Or so we'll be looking at basically navigating research, innovation, and exploring. So for that, we'll be having our panel. Please can we just celebrate the presence of each and every one of them here. So please and please, before we start, I would like to say, get your pen and your book ready. You will learn a lot. I wish I could literally go down to learn, because I'm sure it would be a very interactive session. Amen. So speaking on biochemistry beyond the classroom, I would like to ask our panelists, please, can someone enlighten us, like, beyond being in the class, what are the opportunities, what are the other aspects of biochemistry that we can know about? Because everybody just believes it's to come to school to do practical. So please, I would like to ask, what are some of the aspects of biochemistry beyond the classroom?
Okay, good day, everyone.
Good day, sir.
Please, the question again, so it will be clear.
Okay. I would like an enlightenment, because I believe not every one of us here just wants to do school la cram la pour. So what are the aspects of biochemistry beyond classroom activities?
Thank you very much. So biochemistry beyond classroom activities. We've been talking about research, but there are still other areas that can be explored. We have food and nutrition. That's a great area that can be explored. You could see that you can genetically improve growth of some products. As a biochemist, that can be a major concern to you. This particular crop in this area is producing very well. This particular crop in another area is not producing very well. Why? That's your first question. Then the next question is, how can you make this particular crop be like this particular crop to produce well? That is another question. For example, you look at China, they produce rice very well. Why can they produce rice very well? Yes, because their areas are waterlogged. They have water, they have plants, they have water areas and what have you. Then you ask your question, in dry areas, how can you make this possible? As a biochemist, you can solve that problem. You can find a means of solving that problem. It's just like a common societal problem whereby rice is very expensive here because we cannot produce it as better as in China. That is why most of the rice products are from there. But you can find a way. You can find a way to grow your rice products here and to be conducive enough for them as well. So there are a lot of prospects, forensics. You can solve murder cases. A situation happened in UK whereby someone was murdered in a car and the person ran away. They couldn't find the person. Then they found a mosquito inside the car, a dead mosquito. The mosquito bit the person. They took blood samples from that mosquito and they could trace the person. It's quite unfortunate that we don't have track record in Nigeria, but when we develop, by God's grace, which is very possible, this is something we can accomplish. So as a biochemist, you can do that as simple as possible. Thank you very much.
Thank you, sir. Please, a round of applause to him. Okay. Does any of our panelists have any other thing to add in regards to that question?
Good morning, ma'am. Good morning. I want to thank the biochemistry study community for this opportunity. So before we have beyond the classroom, we have to have while in the classroom. You cannot excel so well beyond the classroom if you're not doing well while in the classroom. Why I'm talking this way is that I am an advocate of corporate world. And in the corporate world, there is a niche for biochemists in the corporate world. It will interest you that for every pharmaceutical company you have all over the world have a research and development part. Yes, they are into research, but they are working in the corporate world. And what will get you to enter into the corporate world is what you do while you are in the classroom. To excel beyond the classroom, you must do well while you are in the classroom. Yes, so many people will say school is scam. But school is not scam. Some of us cannot do without the school. Not every one of us will be entrepreneurs. And there is just so many things to do. For instance, while Josephat was talking, he talked about tech bros. We know what tech bros do. We know how they are going so good in and making money. Imagine combining your biochemistry and your tech bro. And that is a niche that nobody has gone through fully, if you look at it. So you must do well while you're in the classroom to do exceptionally well beyond the classroom. So many people I have read stories about, they'll tell you that they've been able to get jobs in Shell, in Chevron, so many companies without knowing anybody. Why? Because while in the classroom, they were able to excel. That put them outside to do well beyond the classroom. There are a lot of opportunities. There is public health, there is corporate biochemistry, there is biotechnology, there is molecular biology. There is a niche. And for you to go to that niche, you must do well while in the classroom. Nobody will employ somebody that cannot do extremely well. You must do well while in the classroom to be able to pass tests that can take you to the next level. So many people will say there are no jobs in Nigeria, but there are jobs in Nigeria. There are actually corporate jobs. So many people will go into banking. For instance, we have the new MD and CEO of Zenith, right? She studied sociology from where? Here in University of Jos. And she went into banking. So many of us seated here will go into politics. And if you do not like the biochem you are studying now, you know, if you've been following what has been happening in the biochemistry world, they will send a bill in the Senate or send a bill to the president, and the bill will be cancelled and it will not be passed. Why is it happening? It's because there are no people that understand what we are doing. So many people will also go to the politics. That's why you are there. You must be there to be able to give us back to this community. So while you are in the classroom, you need to do exceeding well so that beyond the classroom, you can create a niche for yourself. So that's all I have to say. Thank you.
Thank you so much, Ma. Please a round of applause to our panelists. Thank you so much for enlightening us. So we can see that beyond the classroom, there are so many aspects of biochemistry we can all explore. There's the forensic, as he said, and she also mentioned something striking. She said, you must do well in the classroom. So school is not what? Scam. School is not what? Thank you so much. So the next question, I have come to discover personally that there's a large bridge between the academic and the research aspect of biochemistry. So how do you think we as students, we can bridge that gap? I mean, one of the things I've always looked forward to, imagine being taught about proteins and you get to see these things, like you get to actually carry out experiments. So how do you think we can bridge that gap? Because there's a gap. So is there a way we can have a synergy such that we work hand in hand with the classroom and then still at the same time we have the researches going on? Not that, because we have some people that are all into the research and then there are those that are just all into the classwork. So how can we create that synergy? Can we find a bridge? That's the question between the two. What are the ways we can put in effort to do that?
Thank you very much for this opportunity. So based on the question that you asked, it reminded me of something that one of our lecturers said. The idea of being a biochemist, right, is that this, what you are doing here, what we're all doing here in BSc is all foundational, right? So if you know you are so much interested one day to actually get into research, that is, you feel that you have this calling within you to actually be a biochemist, then you must be sure to specialize in something. Even in many other courses, like all around the world, even go to medicine that looks all high and mighty, right? If you're not like particularly specialized in a particular part in medicine, yes, you can still be a doctor, you can still attend to people and stuff, but you will be sorely limited. There are places you will never go in this life without specialization. So if you know you want to go into research, then you must be sure, okay, what is that thing you want to research about? What is that problem you have seen in your society and you feel like you can provide a solution to it? You need knowledge. The only way that you can get this knowledge is by furthering in this particular field. And if you want to further, that is you going in, like getting specialized in that particular field. You can decide that maybe you want to go into virology or toxicology, or you're interested in food. For example, you want to find a solution to diabetes, but you don't want them to be taking drugs into their body. Maybe they are very old. They make up a mind, okay, I want to figure out providing food, supplements that these people can take that would treat them of this stuff. That is you wanting to go into research about treating diabetes. You must specialize in a particular course, for example, nutritional genetics, in order to figure out the solution. So that is you creating synergy between what you know now and being able to become a researcher in the future. Thank you.
Thank you. Please, let's plan the practice. I hope we are learning. So we can't just be like wildfire and burning everywhere. We have to have a direction. Yes, sir.
Okay, to say something briefly, you said how can we bridge the gap between academics and research?
Yes.
And you cannot go into research without the academics. And if you do the academics alone, it's just like you have the engine, but you cannot move. So you need the engine and you need the part of the car to move. You need the fuel, you need the engine, you need everything to move. I'm lucky enough that one of my supervisors is here, and my research, I was working on malaria. Now, they didn't just give us the research to carry out. Before then, we had what we call seminar. They gave us seminar topics, and we learned about the topic we were to research on. That's academics. If we didn't learn about that, we can't just go in and we'll have too many questions. Imagine carrying out a research and asking too many questions. You are confused. So without the academics, believe me, you'll be totally confused carrying out research. So you need the academics to carry out research. Thank you.
Thank you, sir.
Thank you so much for the opportunity. Not to repeat what everyone else has said, I think the research and the academics are not two different things. I remember the first time I maybe had a very good encounter with a researcher, someone I respected very well. He told me research is simply search and search and search. Like you're already searching. So even if you see a research work, a groundbreaking research, for instance, is one that going through the literature review, you'll see quotation of what has been done before. And so basically, you're just trying to refine knowledge, and then by so doing, you bring a new perspective to it. So I strongly believe that the excitement of research and academics shouldn't make us think they are two different things. Because for me, I was really excited about, okay, let's go research this, but along you discover that you need to have foundational knowledge. You need to, that's when even something as minute as amino acid begins to make sense to you. So when I got that understanding, I felt I had to go back. I still had to go back to maybe my basic knowledge in 200 level, because I feel like you need to really have that foundational knowledge to be able to, because it's the amount of information you have at your disposal that makes it possible for you to think beyond the scope of what you've been taught and make an impact around it. So I strongly believe that what makes you an academic, or your sole aim in the academia, is to be able to redefine the knowledge that has already been, and then find new ways around solving problems. And that's basically must involve having foundational knowledge of the subject matter. It is from that perspective, or from that stand, that you are better able to make more insightful decisions. And then at the end of the day, groundbreaking research is not reinventing the wheels. It is actually bringing new insights to what has already been. Thank you.
Thank you. Please, can we give him a round of applause? Okay, thank you. Concerning that, thank you. Hope we cleared. Hope we all cleared. So we have to, there is no difference between academics and research. It's a two-way thing. It works together. Okay, so the next question, Sam. Concerning innovative thinking, I believe no one wants, for instance, everybody wants to make a groundbreaking research. Personally, I don't think anyone here wants to go and search about amino acids when we already know that there are 20 basic. Nobody wants to go and be checking how many basics do we have. So what are some of the things that students can do to give them, because not everyone that just sits and, oh, is born with it, think different. So what are some of those steps we as students can take that could help us and foster us into innovative thinking, creating new things? Because I believe everyone here, I mean, you want your name to be written on the sands of time. So what are some of those steps we can take as students that will foster such things being actualized?
Okay, thank you very much. So I think when you mentioned innovative thinking, it actually reminded me of a seminar I attended just last year, December last year at Ibadan. So we just had this global health summit I am a member of, and then I got an invitation to attend. And part of what was discussed was innovative thinking, and I got a new insights to it. And then lately, I was seeing a tweet by a Nobel Prize laureate who talked about innovative thinking. And I think at the base of it all is the level of information at your disposal, what you have in your mind. Because innovative thinking is not really about sleeping and waking up. Yes, Mendeleev told us that the periodic table, he saw it like a vision. He slept and then he saw the periodic table, how they were arranged and all of that. But for those miracles to happen, something just needs to be primarily your center of thought. Just like Einstein said the difference between you and I is because I dwell on a thought longer than you are willing to. So it still comes to the basic level of what are we putting in our minds? What are we intentionally thinking about? What are we intentionally feeding our minds with? What information are we letting go into our minds? This has to be done with every intentionality. So the basic amino acids that we're looking at, how intentional have we been able to let this information sink so deep in our heads? It is from that basic level that we begin to think maybe there could be actually 25 amino acids, because you already have this basic knowledge. So I think bottom line is innovative thinking is actually birthed by the simple day-to-day work of what we decide to think about. And what we think about is basically a product of what we put in our minds, what we intentionally put in our minds. And that is very key. And then the Nobel laureate I talked about, he said, take time to develop yourself, take time to understand your passion, and then work with people. Most of the groundbreaking researches we've seen, most of the groundbreaking innovations we've seen, most of the groundbreaking things we celebrate today are not the product of one person's thinking. It probably started with one person, and but it didn't end with that one person. Just like I was reading about Jennifer Doudna and her friend Emmanuel Charpentier. In 2018, they won the Nobel Prize for, in 2020 actually, they won the Nobel Prize for the groundbreaking work on CRISPR, which is a gene editing tool. But this journey dates back to 2002, when they were working. In fact, a lot of persons came in the picture. First working with a Japanese professor, and then along Jennifer Doudna. She studied chemistry at the BSc level, but she had a PhD in biochemistry. And then Emmanuel Charpentier studied macrobiology. So that's how they began working together from 2002 till eventually 2020. And then it was just two of them that won the Nobel Prize. But quite a lot of persons came into that picture. So first, basically, it's the information we have, because at the end of the day, we cannot think beyond what's in our mind. It still has to, our thoughts and the actions we take eventually, and the insights we get, is still connected to what's in our mind. And then you don't have to be a lone ranger in this. I think most of the time, the African mentality is, I want to do it alone, I want to get all the glory. And that's why, for a very long time, Africans are really limited, even in the science space and all. By the time we have the collaborative mindset, I don't know it all. I'm studying biochemistry. I need the knowledge of someone studying macrobiology. He understands the bacterial world possibly more than I do. You understand? And so by the time we have this open mindset to learning as much as we can, first developing ourselves, and then working with the right people, growing the right community. And I think that's what really stands out in this biochemistry study community. It's not a one-person thing. So that way, little by little, before we know it, we are there. Thank you very much.
Thank you, sir.
I would like to go back to the previous question you asked because it's interrelated to this question you asked. So this is where the synergy comes in. For you to have an innovative thinking of something, you must have something you really like. You cannot research on everything. For instance, I'll take HIV as an example. People have studied, that's from biochemistry, from their foundation, and they've learned, and we've seen how it has furthered to, even to this extent that you see somebody that has HIV now, and they are looking so normal. That is because the academics which they've studied before, they grew to love that part of HIV, which pushed them to having a research in HIV. So when I was in 300 level, we learned about gout that's caused from nucleic acid synthesis. Somebody can just decide to say, okay, this is what I want to specialize in. And that's where your own research will start from. Why I like to speak on diseases and drugs is that I, for myself, have found something I like in the pharmaceutical industry. And you just notice that the drugs they produce, they are different, but they are different brands. But you just get that something stands out from one brand to the other. That's because there's just been a little innovative thinking that has differentiated the other brand to the other. So you cannot just go into any research you want. That's why I said the last question you asked is related to this. The academics that you're studying is the foundation for the research you're going to do. In 300 level, you're going to learn about, and okay, we have 300 level students already and 200 level students. You will learn about the metabolic pathways and how their disorders affect us as man. So now, if you want to go into research as a medical scientist or something, you know that that is the path you're going to. You come to 400 level, I don't want to do research. Oh, this is my best subject. It could be metabolism of proteins, it could be metabolism of nucleic acid. You could come to 400 level and you see that you like molecular biology, you like genetics engineering, or you like industrial biochem. Those are your foundations. That is where you will see where next you want to research and where you want to think innovatively. So don't be everywhere. It will just put you out of the radar. And other things that could help you is begin to study, begin to attend seminars. I know, yes, they are expensive, but some are free. Begin to attend seminars, begin to get to be different, and you can learn some things that you can inculcate into your life. So that's what I have to say.
Thank you so much, ma. Please, can we just give her a round of applause? So time is really against us.
Production, and then they do pre-implantation genetics diagnosis. Caught my attention, and then